Oh, let me turn this truck off. So it's crack of dawn right now, and I came out here to record the moon, but as I got closer to the park, the clouds, the moon got lower and lower on the horizon, and sorry, I have to keep wiping the camera because I just brought it in from inside the air condition, so the humidity on the lens keeps moisturing up the oh, now it's gone. So yeah, if you're gonna have pictures of the moon or in the morning time, it's use the AC and it's warm outside, you gotta leave your camera like in the car, or you know, in the environmental temperatures. So, but it's the crack of dawn right now, and the moon is setting over the horizon right now. It's really foggy. It was really cloudy last night, so I didn't know if I'd be able to get the moon this morning, but I looked out my back window and there the moon was, and I thought I'd be able to get here quick enough. My stupid butt went and grabbed a cup of coffee instead of coming straight out here. And I thought I'd be able to come out here longer. So but I guess that is going to be the end of the moon because of all the clouds. See if it comes back out or not. Oh, there it is. There's a piece of it. You can't. I don't know if the camera's picking it up. I don't think so. It's right there. Wipe this lens off one more time. There we go. Boom. See now, these clouds come and go. Now, this is why the moon is small, close, and local to everybody's perspective. Because this fog and shade in my area isn't everywhere, and it's blocking out the moon for me. But at this angle, at 6 in the morning, you know, the moon's supposedly 6, or I won't even say 6 time zones. I'll say 3 time zones. That's not where the curvature of the Earth is, right there on, you know, on the other side of the Atlantic Ocean, or the Oceanic Ocean, the Pacific Ocean. It's not. That is not the curvature of the Earth for me. It's not on the other side of the United States. It's right here. Like my clouds are blocking it from my perspective. This fog is blocking it from my perspective. And this 10-mile zoom camera can zoom in on the tiniest detail of the moon, which tells me that it's close. So I'm sorry that I couldn't get a better picture for you guys and whatnot. It's pretty out here though, with all this fog. This is the park I always come to. See if I can get in real close. Why it's not gonna pick it up. Oh, it's getting worse. There's a moth bothering the shit out of me. So yeah, this is the park, the river bend that I come to. but I could see it really well when I was down this way to the south, and then as I came here, it went behind a cloud, you know, because it's like centered to everybody's perspective. So yeah, you'll notice the moon will travel to you and stay at a certain distance. So as it's setting, it's getting slowly away from you, but it's still not that far. As it's rising and setting, the sun and the moon aren't that far from you, but they stay at a centered distance from you. So like on an east to west highway, the shading in the cloud or the distance, it will move very fast, but north to the south, not so much. Like because you're moving side to side with it instead of to and away from it. So the clouds will change drastically. The shading of them, the ones they're behind and front of, will change drastically as you move to and away in the areas of it. But when you're moving up and down, side to side, to the sun and the moon, not as much. But that's all I really got to say. Like, yeah, people also ask why you can't see that far across a flat plain. Well, fog. Fog is a big reason. Smog, blah, blah, blah. And the horizon rises to eye level, so everything pancakes out. But good morning. Yeah, but if you think that my clouds are over the horizon, these clouds right here are 20 miles down the road out west. They're not over the curvature of the earth, so there's no way that my clouds are blocking the curvature of the earth. And the moon only illuminates the nearby clouds, so therefore it has to be close to each observer. Point blank period. Anyway, I'm gonna get going because the moon's gone, and the reason I came out here is because of the moon. I'll come back out tomorrow this time, and maybe I'll get it better. The moon moves about an hour slower than the sun, but it rises and sets quicker because it's lower. So I'll have more time out here if I get out here at 6:30 tomorrow to show more observations of how it's close. When it's at an angle like this, you know, setting like at a 9-10 o'clock angle, it's really easy to tell because the moonlight will be inside of those clouds, and inside of these clouds the shading will be lit up on the insides of them. So it's best to tell with the sun and the moon that they're close and local to everybody's perspective based on how the insides of each of the clouds are being shaded, and the distance at which you're told on globular levels on the heliocentric model that, you know, at 9 o'clock it's 3 time zones away from you, but you know the clouds in your area aren't 3 time zones away from you, and you know that right now it's 6 in the morning, so that's 6 hours after midnight. The moon moves about an hour slower, so you divide that in half, 3 time zones. That moon isn't 3 time zones away from me. It's within my clouds. It's only illuminating my nearby clouds. I can't see over the curvature of the earth. I can't see that far. Could you imagine seeing through 1,600 miles of atmosphere? You just couldn't do it. It'd be impossible. Anyway, love, peace, and hugs. In this recording, y'all have a good day.